Okay, we're going to add in the stuff that I talked to you about having this thing help you do a better job of fitting than just eyeballing it. So I'm going to go up here to the top left, and I am going to add another column here called residuals. And then I'm going to add another one here called chi, and there's a caret thing. You shift and hit the 6 key and you get a little caret, chi squared. Okay, so residuals is pretty straightforward. The residuals is the data here minus the fit. And the fit is your slope and your y-intercept. Okay, so we're gonna go here equals data minus the fit, and then we're gonna hit enter, and then going to fill it all in. All the way down. This is just a generic file. We've seen the top 5 numbers before, but for the linear acceleration lab. Okay, so now we want to add this thing called a chi-square. Now I'm going to pause this thing and make a picture of the equation and then paste it into here so you can see it. Okay, so now this picture right here has magically appeared, and that's a Greek letter chi. I was just lazy for us here. So anyways, we got the chi-square. So the chi-square is the data minus the fit, which is also the residuals up here. And then, but this time I square it, and not only that, I divide by the error on the data. So each one of these here has a sigma and error. This is the y values and the error on each y value, and you see the error bars here. Okay, so I'm going to use a function, a built-in function of Excel, because I want to square these things, and it's called power, P-O-W-E-R. And so then I make an open parentheses, all the functions. Now you see it here, all the built-in functions, you need parentheses. So that's the number you want to square, and that's the power, and there's a comma in here between them. So I'm going to create a number actually, because I want to do this is the residual, which is nice. I have it over here already, and then I already have the sigma, and I could just as soon put parentheses around everything and have a square out here. So what I'm going to do is I'm going to literally put another set of parentheses in here to make sure that the division goes right. So I'm going to say that I want to do the residuals divided by the sigma, close it up. So I click on the box to get these to appear up here. Then it's comma 2 because I want to square it, and then close the parentheses, and now I get a number, and of course here it's 0 because this is 0 and 0, and there's no difference. Okay, so now, very simply now, I just drag this here down, and I fill it all in, and I got a whole bunch of numbers. And that's all the various chi-squares. And then notice that one thing to notice here, so let's find one where the sigma is large. And so if the sigma is large, here too, the chi-square number is larger than the neighbors, even though the fit here is pretty good. What that does is well, wait, we're not ready for that concept yet. Just notice that. Okay, now one thing I'm going to do right quick here is I'm going to select these boxes, and as we've done before, I'm going to right mouse click, borders, and all borders, and it just makes it a little easier for us to see. And I'm going to do it here. We've already done this before. Borders, all borders. Okay, so now we are going to do one more step. We're going to sum the chi-squares. So we're going to call this SUM. See where I am here? We could use a capital sigma, but we'll be lazy again and just type it in, chi-square. Enter. So what is that? We want to sum all these chi-squared values. So here, here we type in SUM, and oops, I forgot, well, equals. Gotta always put equals. SUM. There it is. There's choices until I do the open parenthesis, and then it's going to sum up all the numbers. So I'm going to choose all these chi-squared values. Dun dun dun. Right down the line. And then I'm going to close the parentheses up here, and this call is the formula bar, and hit enter. And then I'll see a number here. And in fact, what I'm going to do here is I'm also going to select all these and put border around it. All borders. Now, watch what happens when I change this slope number. Now, I see that my fit line now is pretty darn good, but also notice that the chi-square went down. Went from 4,000 to 489. So now what I could do is 9.6. What happens? Oh, it kept going down. Neat. And the fit line looks better. So let's go down a little bit more. Raise the slope a little bit more. 9.7. Oh, it went up. Okay, that's too much. So now I'll go 9.65. And now it's even a bit lower. So now we have a way of making sure that the fit is as good as we can without using some fancy computer program other than just Excel. Now, Excel has a built-in way to get this number. We'll get to that another time. Now here, I want to once again point out to you now, the fit's very good, huh? But we have these ones here, and these are probably where the data point is way off. But notice that these ones with the smaller, well, I guess it's not so true, so bite my tongue. But anyways, here's a great example. It has a big error bar down here. The line passes right to the middle, but even so, the chi-square is really low. So it doesn't have much effect on the sum. The ones that have the most effect on the sum are the ones with the smallest error bars, but that's what we would expect, because those, when we draw the line by hand, we know that it's the ones that, as long as the red line fits through the error bars, are fine. So the ones with the small error bars are the ones that trap us. Okay, so now one more thing we could do is we can make a plot of the residuals. So in that case, we select we want the same axis, x-axis. So we click and select that column. So I'm showing you a little bit different way to do this. Now, because the column I want is not right next to it, I have to hold down the control key and then click up here, E. So now I've got two columns that are not next to each other. And now I go up to the top here, I go to Insert, and I go to Charts, and I want a scatter plot. just like that. Okay, so right off the bat you can see that there's something a little screwy going on here because this is artificially created data. But if I were to see this, I would be worried about a systematic error. Now we can let's see if we increase right, what if we make this go to minus 0.1, for example, minus 0.1 y-intercept. Well, that does something. I still see this sort of angle here, but then again, like I said, it's screwy data. What we would, artificial data, what we expect to see is scattering. We want to see the scattering be random above and below the zero. Now, I want to show you, I'm going to try to show you why the chi-squared is a better thing to do than it is to use the residuals. Now, for example, I can make a sum of the residuals. All right, so sum resid, and then I'm going to say equals sum open parentheses, and then I'm going to select all the residuals, and then I'm going to close the parentheses. Okay, so now let's take a look at that, and that sum is pretty darn small. Oh, cool. But one thing is, though, I could do something like this. I could make this y-intercept really crazy. So it's way up there. Look at what happens. The chi-squared goes nuts, right? So now let's get this slope. Let's make it 5. So now notice that the residuals went down. And in fact, I can probably work this. Now this is very similar to the pivot point that the other lab told us to do. And notice that I can begin to get the sum of the residuals down very low, but this is not a very good line, is it? It's not a good fit line. So because the chi-squared uses this square, it means that there's a minima that's reached in a different way than the residuals is done. And again, we'll talk more about that as time goes by. So I'll restore the y-intercept of 0 because it's what we expect for this data, and then I'll restore this and see the residuals are back low, but now the chi-square is low, and the plot looks like much better than we would like, much better in the way we would expect it to look. All right, so stop this and good luck.